meant no restraints. I built an MRI simulator, which I parked in our living room. We constructed mock-ups of the head coil that picked up signals from the brain, and Mark and I quickly taught Callie how to shimmy into it. Although the process was mostly trial and error, and we hit many speed bumps along the way, it turned out not to be as difficult as we initially thought it would be. With just a few months of training, Callie had graduated from a discarded dog in an animal shelter to the first dog to have her brain scanned voluntarily while fully awake and unrestrained. Encouraged by our success, we solicited the help of the local dog community to join this groundbreaking project to investigate the workings of the canine mind. Much to my surprise, we had no shortage of volunteers. So many volunteered that Mark and I developed a tryout protocol so we could identify the dogs who would be most likely to succeed in MRI training. Within a year of Callie's first scan, the team had grown to nearly 20 dogs. To accommodate all these dogs and people, we held MRI practice every Sunday afternoon, alternating weeks between the A team and Bravo company. We began with very simple experiments to see how dogs' brains responded to hand signals that cued the delivery of treats. In humans, it was already known that a key brain structure, called the caudate nucleus, responded in anticipation to things that people liked, such as food, money, and music. So when we discovered that the dog's caudate reacted similarly to hand signals in anticipation of the treats, we knew we were on to something important. The dogs took this all in stride as just another fun activity they did with their owners, and their brains responded much as a human's would to a pleasurable experience. As the dogs became increasingly accustomed to the MRI, we were able to design more complex tasks for them to do. When we presented smells of people and other animals to the dogs, we found that the reward response occurred in the dogs' brains only for the smells of the people in the household, and not for the smells of the other dogs. Because food wasn't directly linked to these odors, this was the first hard evidence that dogs might experience something like love for the people in their lives. The dog project soon consumed my life, eclipsing the human work in the lab. Because of its potential to improve the training of military working dogs, the Office of Naval Research began supporting our research, and we expanded the number of dogs in the project as well as the complexity of the tasks they performed in the MRI. Not only was it fun, but I had the feeling that we were on the verge of gaining new insights into the minds of our best friends. As I learned more about the canine brain, I became convinced we had much in common with dogs at the deepest levels. The same basic structures for emotion could be found in both dog and human. But there was a bigger question here, beyond one of emotions, which I had conveniently suppressed as we had built up the dog project. The question came to the surface at a conference on vegan issues. I had been reluctant to accept the invitation to speak because I wasn't a vegan, but the organizers assured me that they just wanted to hear what we were learning about the canine mind. Personal eating practices were not on the agenda. That might have been the plan, but it didn't turn out that way. After my talk on the dog project, a fellow speaker accused me of being a speciesist because I gave dogs special status, even to the point of feeding them the ground-up flesh of other animals in the form of hot dogs. It was an awkward moment, and I felt duped by the conference organizers. Was I a speciesist? Probably. Was that bad? I didn't know. 4 years into the project, there was no denying that our work had raised a bigger question. If we had evidence that dogs experienced emotions similar to those of humans, what about other animals? People began asking me whether cats could be trained to go into the MRI, and occasionally about whether pigs might be trainable. I knew that wasn't likely, and scanning sedated animals didn't seem ethical or likely to yield much useful information about animal cognition. I was at an impasse. The possibility of studying other animals seemed a fantasy. The turning point came when Peter Cook joined the lab. Peter had come to the project from Santa Cruz, California, where he had completed his PhD on sea lion memory. He was passionate about figuring out how animals' minds worked, especially in their natural environments. California sea lions, though, had been stranding in large numbers. Some of the sea lions could be rehabilitated, but others suffered from